Hi, I'm Katie, and this is What is Deployment Anyway? This isn't a talk about the one true way to deploy your application. This talk is full of opinions, but mostly it's a review of the world of deployment as it is in the year 2020. This talk is going to dive into the complexities of deployment, in essence answering the question, well, what is deployment anyway? More specifically, what is Django deployment anyway? I'm choosing Django here for a reason that will become apparent later. Some of the points of interest along our journey today. We'll start by looking exactly what comes out of the box with Django, and then we'll discuss some of the complexities Django has compared to other web frameworks when it comes to deployment. We'll also discuss some of the helpers that Django has to assist us along the way. This talk and the code examples are specifically for Django 3.0.5 and Python 3.8.2. If you're joining me on YouTube from the year 2028, I'm sorry this talk might be a little bit out of date, but hopefully you'll still learn something. We're also just going to stick to the base Django today. No additional features, nothing asynchronous, no task management, no other helpers. Just whatever comes out of the box in stock standard Django. This talk should be useful if you're anywhere from looking at Django for the first time to working out how to deploy your DjangoGirls tutorial project, or if you want to just a refresher about what Django is all about. So let's have a look at Django as it comes out of the box. So let's open up a new terminal and pip install Django. Now I have Django installed, but I can't do a lot yet. What I need is a Django project. I can create a template Django project by running Django admin start project. For my template, I'll call it my project, and I'm going to install it to the current directory. Now I get a whole bunch of template files, especially the manage.py file is going to be super useful, and we'll be using this file a lot. From here, to run a local web server, I need to run python manage.py run server, which will start a local web server for me. But there's this great big honking red error message talking about unapplied migrations. There is a helpful suggestion that what I should run to fix this though. So let's stop our web server and run python manage.py migrate. Hey, a whole bunch of successful output. It looks like it's run all the migrations for me. Has it done anything to change my local file system? Let's have a look. Hey, there's a database file there now. This should be useful. So let's try running run server again. And I no longer get a great big red error message. I do get suggested that I should go to this URL and hey, the install worked successfully. Congratulations. I now have Django running locally in a template project, and I can navigate to the admin and I can start developing my Django application. It is really simple for us to get our application working locally, and that's down to Django's local development story. Python manage.py run server does everything we need to get Django running locally. It serves as a local web server primarily, which is extraordinarily useful for local development. The documentation describes what run server does as starts a lightweight development web server on the local machine. Sure, but a couple of paragraphs down, in big capital letters, do not use this server in a production setting. Don't! I can't tell you how many times I've seen this run in production, but the documentation says right there, don't. It has not undergone any security audits or performance tests, and that's how it's going to stay. We are in the business of making web frameworks, not web servers. Django is in the business of making web frameworks, not web servers. Django is an extremely stable, production-ready web framework. It is very good at being a web framework. The fact that it provides any local web server functionality at all is amazing, but it calls it out explicitly that you do not use it for production. We will need to replace the local web server with something else. The documentation has brought up a couple of terms that we really should describe. Particularly, what is production anyway? Well, production is a live environment. But why is it called production? I've asked this question of a couple of Python practitioners, many of whom have more than a decade of experience, and the question leaves them thinking. The best I can find is a paper from the 1950s which compares producing computers and computer software to a production line. In the local web sense, however, think of it as more of a theatrical production. You have all the back-end stuff working with the lighting and the sound to put on a performance that your user sees. But what is a web server anyway? Thankfully, that one is a little bit more aptly named. A web server serves websites. There are local web servers like Run Server, but there are also production-grade web servers. A web server is the service that responds when you enter a website URL into your browser and deals with things like HTTP protocol, handshakes, content types, and whatever. Run server is our local web server, so it serves our local website, but it also acts as a static server. What is static then? Static assets, media, this refers to the unmoving parts of our website relative to the dynamic parts. Assets might be pictures, videos, user-uploaded content. It's the stuff that we can store locally on disk and serve as needed. As we look at the documentation, we can see that serving static files in development happens if we have debug enabled and if we've got contrib static files in our settings. Sure, but also the documentation for static files also says that it is not suitable for production use. This is yet another local development helper, so we will need to find something else to serve our static later on. Our third major element that we have is databases. Now, we saw this earlier where there was this file that was automatically generated for us. That file was created because we had a default configuration in our settings file, which defines that SQLite 3 will be our default database engine. This means that we will use SQLite. SQLite, according to the documentation, is an excellent development alternative. SQLite happens to work as a local file to store the database, but again, we are going to need to find something else for production. Django's ease of use in development makes it extraordinarily easy to get started and get developing, but for all these helpers, none of them can be used in a production setting, which makes Django complex. Not complicated, just complex. Django doesn't provide you with a web server or a database that's production ready. It doesn't do anything about static files, so you're going to have to provide your own. And if you aren't familiar with the production grade offerings out there, you'll end up getting confused or worse, leaning on using the development systems in production, which you should not do. However, now is an important time to mention something else here. Compare the out-of-the-box functionality of Django to something like Flask. A lot of tutorials you'll find online say, here's how to deploy Python to production, and just give you one app.py file with a hello world. No database, no static, no complexities. And this makes it really easy for them to say, just copy this code somewhere and it'll run. It's easy. But this is because of one simple fact. State. Django is a stateful application. It has a database requirement and static assets requirements out of the box. Flask by default does not. A sample hello world in Flask doesn't require a database or images, so it's so much easier to deploy. Yes, you can connect a Flask application to a myriad of other backing services, but by default you do not have to. So the simple hello world works. Stateful applications, however, are complex. And this is why I chose Django for my context today. If I'd chosen Flask, this would have been a lightning talk. But it's not just Django. Anytime you care about persistence, you add complexity to your deployments. And funnily enough, this is also mentioned in the documentation. Back on the page about serving static files in production, it mentions this wonderful little gem. Every production setup will be a little bit different. Every production setup will be a little bit different. I don't know who added this to the documentation, but it's been there for about a decade at this point, and this is such an important point. It depends is the line that I hear in nearly every other deployment talk I've seen. When trying to tell you the one true way to do deployment, it depends. And that's correct. But I'm not going to use that line. Instead, I'm going to use this take. I'm a sysadmin. I am not your sysadmin. I am a sysadministrator. I'm an operations engineer. I've been an SRE. I've been an automation engineer. I've been doing this for nearly a decade at this point. I've worked for web hosting providers, for platforms as a service, and now for an infrastructure as a service. Each and every deployment is different and unique and beautiful and complex. To deploy any stateful application, you're going to need three things. You're going to need somewhere to run your web framework, and then you're going to need to think about your state. You need to connect to your database, and you probably need to serve static files. This is the same trifecta for Django. To deploy a Django application, you're going to need to run a web framework, connect to a database, and serve static files. These requirements require you to connect to state. It also requires that you need somewhere to run your web server. Django has helpers for this. In order, they are WSGI compatibility, the migrate command, and the collectstatic command. The rest of this talk will be describing how these helpers work and how they can help us when deploying our application. So, step 1. We need to be able to run Django. As I mentioned, Django is WSGI compatible. WSGI stands for Web Server Gateway Interface, and it's a Python standard for web servers. But what is WSGI anyway? WSGI is a standard interface for Python applications to talk to a web server. It's a Web Server Gateway Interface. It was a standard proposed back in 2003 as PEP 333 as a prompt to standardize the interface between web servers and Python web frameworks. It allows us to choose any web server we want that understands WSGI and use it with our Django application. As per the documentation, Start Project itself does do a minimal WSGI configuration for you, and that was that wsgi.py file. This file includes all the information that WSGI needs to be able to get a callable that can run your Python application. Carlton Gibson did an entire talk about these 4 lines. To deploy a Django app with a WSGI web server, you're going to need a WSGI web server. 2 of the most common WSGI web servers are MicroWSGI and GUnicorn. Each of these web servers have their own dedicated talk. So how do you deploy a WSGI web server? Well, there are going to be many options to choose from and many ways that you can go about this. But I have a better question. How much custom infrastructure do you want? Because as we saw before, every single production setup is a little bit different, but there are many choices out there that will work for 80% of cases. If you have a standard Django application, and if you don't have any strong opinions about added complexities or specialist systems, 80% of the time, these systems will work for you. More importantly, how much infrastructure management do you want to do yourself? If you're a Django developer, you probably want to develop in Django. You don't want to be spending your time managing your infrastructure. And I mean, sure, it is super interesting to be able to set up your own physical server, your own network, your own web server, your own redundant power, your own everything. But when you just want to get your application online, why not pay somebody else to do that for you? And again, we don't have anything custom in our setup, and we don't have any strong opinions about anything, so why not just let somebody manage that for us? What do you want to worry about? As a sysadmin, I used to get paid to worry. You're a developer. A little worry is good, but thankfully you can pay someone to take that away. This is what we know as managed hosting, because you pay for your hosting to be managed for you. There are 2 main types of managed hosting providers. There'll be the platforms as a service or infrastructure as a service. These are normally shortened down to PaaS and IaaS because words are long and terrible and we're technologists that need to save letters everywhere. And yes, this is a non-exhaustive list. Within the scope of deploying a Django application, these are the 2 main options. There are others. You could go as detailed as running your application on a server that you have compiled yourself on your own custom hardware, the scenario I mentioned earlier. Or you could try to squeeze Django into a tiny little square and put it as a function as a service. But these are the 2 extremes. These are not standard cases. They are absolutely valid if you want to do that, but I'm talking about the 80% of cases. The 2 options that I mentioned are platforms as a service and infrastructure as a service. With platforms as a service, these are your general hosting platforms that sort of handle Django and major web things. These systems, you worry about your Django application and your data, and they will worry about the web server, the operating system, the hardware, the storage, the networking, and everything else. Normally, you do not get a choice of any of the things that are managed for you. If you need a choice, you often have to drop down a level of complexity and use infrastructure as a service. In these systems, you worry about which web server you want to use, which operating system you want to use. Often, you have to think about it in terms of a container or a virtual machine. But the provider manages the hardware, the storage, the networking, etc. for you. Now, this is very much a generalization, and there's an entire other talk about this, I'm sure. There is a reason that I mention this. What do you want to worry about? If you don't have an opinion, choose a platform as a service. If you have a little bit of opinions, choose infrastructure as a service. So, that's how to run Django. Now, what about that database? Django provides us with two management command helpers, which, in my personal opinion, are two of the greatest features of Django. Oh, sure, having a dynamic web administration portal is pretty cool too, but these commands are just choice. Python manage.py make migrations and Python manage.py migrate have been explicitly created to reduce developer toil. They automate the entire system of migrating your Django models into SQL for whichever database you want. These are the commands that we had to run earlier in order to create our major database structures in the beginning. They deal with things like the admin side, content types, authentication, and these are the things that the admin needs in order to be able to work. So, which database do you choose? I mean, Django lists a whole bunch of databases that are compatible and a whole bunch of third parties that are also useful. But not all databases are created alike. What do you want to worry about? If you already have a database expert in your company, use the one that they know. If you have a preferred database, just use that. Otherwise, just use Postgres. I know, right? I'm actually telling you a solid opinion, but it's not without reason. The documentation backs me up here. Django is a database agnostic web framework, but Postgres has a number of features which are not shared by other databases Django supports. The ability for other databases to have as much breadth of functionality is limited only by community contribution, and at the time of recording, Postgres has the most community contribution. If you want your preferred database to have more support, help out by supporting its functionality in Django, or, in the case of Postgres and MariaDB, contribute to the database themselves. They are open source projects, and they're only as strong as their contributions. So now that you've chosen the database that I told you to choose, now you've got to host it. There are a few options here. You could set up your own containers or your own virtual machines and configure a system package install from Ubuntu that installs Postgres and have to deal with your caching and your replicas and all that. Or, what do you want to worry about? Are you a Python developer or are you a database administrator? Managed databases are a specialized as a service offering that a lot of cloud places have, and they are managed databases. Databases are a thing that many programming web frameworks and web languages and formats, web, mobile, all other myriad of things need. Databases are a shared commodity. That means that there is a stable, robust, generic solution that will suit you. In a managed database world, you have to worry about your Django models. Django worries about the generation and application of these migrations, and then your managed hosting provider will deal with storage, backups, persistence, and maintenance. It's a very good idea that your web server and your database are located close-ish to each other so they can talk to each other over the network as quickly as possible because, light only travels so fast. But honestly, managed databases are a really good idea, even if they are the only thing that ends up costing you money. Because at the end of the day, your website code is going to have a copy on your laptop, on GitHub, on your source control system, wherever, but your user data, that may be your only copy in production. So it's a good idea to make sure that it's stored properly and that it's backed up and your database has maintenance and that your managed hosting provider gets to deal with the things like zero downtime, disk expanding, and all the rest of that. Because as somebody who used to get paid to have to do this manually out of hours, I am so thankful that I can pay someone else to have to worry about that for me. And for a Django application hosted on, say, Google Cloud or another cloud provider, your managed database may end up being your only cost. What with the free tiers for compute and storage and the like, your managed database has costs involved, but it's worth paying for that peace of mind. Okay, it may not be your only cost. You may have to pay for that custom domain and other non-free things, but we're not going to explore that kind of complexity today. So that's databases covered. And now finally, static files. The helper here is manage.py collectstatic, and thankfully at a previous PyCon there's been an entire talk dedicated purely on static asset management in Django. The four main options you have here are simple assets, cloud storage, media uploads, and the more complex asset compilation. If you happen to have chosen a infrastructure as a service provider earlier, they often have some sort of cloud storage that is super useful, again, if you want to have everything physically close. If you went for a platform as a service, perhaps you want to use the simple asset management instead. If you're going to be using cloud storage, you're probably going to be wanting to use the Django Storages package, which allows you to integrate with most every cloud provider natively in your Django application. Cloud storage in the world of cloud computing is old. AWS S3 launched in 2006. That's 14 years ago. Storing media objects is a foundational service provided by most cloud providers. And like databases, object storage is one of those foundational infrastructure services shared by many languages and frameworks, so robust generic solutions already exist. Leverage these where you can. Do not create your own. So that's it. We know how to run Django, we know how to connect to a database, and we know how to serve static files. So finally, to answer our question, what is Django deployment anyway? Well, Django deployment is copying your code somewhere, updating the database if you need to, updating the static if you need to, and then running the web server. I know this doesn't seem like a lot, but given that I've just spent the last how many minutes describing all this in detail, hopefully you now have a greater understanding of the complexity, but not exactly how to do it, because there is no one answer here. Even though I've described the sort of things you have to think about, I haven't told you how to do it. Because the way that you do your deployments, the way you set up production has to work for you, because you have to maintain it. If I were to tell you a solution, you may not like it, or heaven forbid, you may not understand it, which means you're not going to be able to maintain it. I can't do that for you. There's so much more to this topic that I can't even hope to cover today. Each one of these things listed here, they're their own conference worth of material. But hopefully I've been able to help you see just a bit behind the curtain of deployment and to show you that, yes, it is complex, but it's not as complicated as you think. This talk has been full of my own opinions, but I'm sure you all have opinions on your own. Sadly, this event has no real hallway track, but my email and my Twitter handle are listed on this slide, and I would love to chat to you about these things, and hopefully I will see you at a PyCon real soon.